In today's tutorial, I'll be walking you through the topic geometric sequence. What is geometric sequence? The terms used in geometric sequence and how you can solve geometric problems. Sit back, relax, and let's dive into it. Geometric sequence. So, what is geometric sequence? It could as well be referred to as geometric progression. Now let's take the definition of what geometric progression is. GS is a sequence in which each successive terms of the sequence are in equal ratio. Geometric sequence is a sequence in which each successive terms of the sequence are in equal ratio. Now, if you remember very well, when we treated arithmetic progression, we had nothing to do with ratio. We had difference. Now, when we treated arithmetic progression, we were able to understand that in the case of the difference, we add, but when it comes to GP, we multiply. Now, sequence in the sense that the terms, the rate at which the term changes, unlike AP, which is more of a linear progression. But in the case of arithmetic, in the case of geometric ratio, it is the changes in the term is exponential. It rapidly changes. So now let's just take so in terms of the GS, it exponentially changes compared to that of arithmetic progression. Arithmetic progression, it's more of a linear progression, but in terms of the geometric progression, it's more of the exponential changes. So that's I hope that we have understood. So let's take down the terms. So what are the terms used in GP? So we have terms used in GS. So just like we have in our arithmetic progression, where we have the first term, the difference, and the end term. So here in in geometric progression, we also have the same thing, where we have the end term, which we denote as this end term. We also have the first term, which is A, first term. We also have the ratio, the common ratio. The common ratio. We also have number of terms, which is n, number of terms. So we have that as that. So to further explain what all this means, let's Z be the first term, let R be the common ratio. So we have ZR raised to power 0, ZR raised to power of 1. We have ZR raised to power of 2. We have ZR raised to power of 3, ZR raised to power of 4, and ZRN. So we can say ZR1 equals ZR, that's 0 minus 1. Then we have ZR2, which is ZR raised to power 2 minus 1, which is this. So we have ZR3, which is equals to ZR3 minus 2, and we have, we can see the board clearly. So we have ZR4, which is equals to ZR, we have raised to power 4 minus 3, and it goes like that until, okay, let me just divide this. It goes like that, and we have so until we have ZR equals A. A is the first 10, R is the ratio raised to power n minus 1, and that is our formula for solving geometric progression or geometric sequence. So I hope this is all well understood. So let's plug this in solving a question, and let's see what it means. Find the common ratio in each of the following. We have 2, 6, 18, 4, 1, 6. We have 1, we have 1, 2, we have 1, 4, we have 1, 8, we have 1, 16, and that's are the questions, and which the instruction is to find a common ratio in each of the following. So how do we get our common ratio? So the first one down here. So now to get our common ratio, we can go for, so let's just name this we have R1. We can just name it R1, R2, R3, R4, and we have this as R5. So we can just go, then we say A, R, let's not forget it has to be the R, according to the illustration I gave from the onset, it has to be the R, which is just right up before. So we can just go for, to get our R on our ratio, we just go for AR3 over AR2 or AR5 over AR4. So going by this, AR3 is 18 and AR2 is 6. So we have 3. Going by AR5 is 162, and we have AR raised to power 4, which is 54. We have 3. So that's how to get the common ratio. Very simple and straightforward. So we can just attempt the second question. So let's just label this as well: R1, R2, R3, R4, and R5. So you can just do, let's do AR raised to power 3 over AR raised to power 2. which is a raised to the power of 3 is 1 over 4, and we can just, it's not going to be the same process now because this is division. We have the numerator and the denominator, like what we have here. So we're just going to do 1 over 4 multiplied by 1 over 2. So we have 1 times 1, which is 1, and we have this multiplied by 8, is 8. So this one can still be 2, so it can still be 1, so it's still 1 over 2. So and if you try the same thing with the others, so that's how it goes. So we have as that. So we are good to go. Example 2. So we have find the 8, 10 of the sequence. We have 2, we have 4, we have 8, we have 16. So how we get this? So we have solution. So our formula says formula a r raised to the power n minus 1. So we have our fourth term, which is equals to a is 2, our r is unknown, and we have to find eighth term, which is 8. Okay, we have to find the eighth term. N is 8. So now to get the common ratio, so we have r equals so let's start with these r1, r2, r3, r4. So we can just do ar 4 raised to the power 4, then we have ar raised to the power 3, and we have 16 over 8, and that gives us, so find the eighth term of the sequence 2, 4, 8, and 16. So we have a question. First thing, we have a formula, which is ar raised to the power n minus 1. So we have our first term, which is 2. We have our ratio is unknown, and we are to find the eighth term. So we have to find the eighth term. So to get our r, let's start the sequence. We have r1, we have r2, we have r3, we have r4. So now, as the formulas dictates, we have ar raised to power, let's pick r4 over ar raised to power 3. So we have for r4, r raised to power 4, we have 16. Then we have ar raised to power 3, we have 8. So our ratio, common ratio, is no longer unknown as we have solved for it. We have 2. So that's that. We've gotten the common ratio. So the instruction, all we have here is just for the fourth term, we have to get 8, we have to solve for 5, 6, 7, and 8. There are 2 ways to doing this, so I'm going to walk you both ways. So the first way is actually is more of a long cut, is a long journey, a longer route compared to that of the second one. So let's just take it together quickly. So for um, term 5, T5, what we'll do, we are going to multiply T4 times the ratio, which is T4 is 16 and the ratio is 2. So we have 16 multiplied by 2. That's 32. So we have 32. So we have R5. So to get for T6, so we have T just to signify term. All these are actually terms. So we have T6, we are going to multiply T5 by ratio. So now, so T5 is 32 multiplied by 2. Then we'll get our answer. Then we have for T7, which is, we have T6 multiplied by R. Then we have our T6. Okay, we are yet to solve for T6. So we have T8 equals T7 multiplied by R. So now to get R, so we have 32 multiplied by 2 gives us 64. So here we have 64 multiplied by 2. That's 128. So we have 128 multiplied by 2, 256. So we have, so for T5 we have 32. We have for T6 now we have 64. We have 128, and we have 256. So we have, so for our 810 we have, for our 810 we have this. That's our final answer. So that is the first route, which I said is a long route. So so we just concluded the short route. So we just conclude the longer route. So now, for example, this is just the 8th term. If you're asked to find, for example, the 500 terms, you can't just keep, it's very impossible, like almost impossible for you to keep multiplying, R till you get to 500. So now, this is what you have to do. So you just apply the formula, which is A R raised to power n minus 1, which is equals to, you already have your A, which your A is 2, and we already have the common ratio, which is 2 as well. Then our nth term, which is 500 minus 1. So we have 2, we attend to the one in the bracket first. So we have 2 bracket 499. So we have 2. So I need to use my calculator here. So we have this 2. We have to address the one in the to address the one in the bracket first. So I have 3.2734. So guys, as you can see, it just keep increasing exponentially. It starts gradually, but over time it increases exponentially. So that is that for that on geometric progression. Thank you very much, guys. Thank you for sticking around. I believe you understand this well enough, and if you have need for better explanation, you can as well reach out to me. I'm very much approachable and available. Thank you very much, guys. If you are yet to subscribe to the channel, do well to hit the subscribe button, like, share, and look forward to seeing subsequent tutorials. Bye bye.